I will have a few hopefully interesting things to say from where you just left about what kind of relevance Aristotle can have or could have on a scientific understanding of the world. So I will try to give a few examples of the kind of prevalence, the relevance I think he has. And to my surprise, I discovered that I also understand, as long as it's on Aristotle, I understand every language. So I had zero knowledge of Italian, but it was surprising that when it's on Aristotle, you understand it. So I want to start with some general remarks. So as is well known, almost a cliche, there's a prevalent mode of thinking in modern science, which involves and we might call an active resistance to, or at least a distance or distaste for Aristotelian ideas. This attitude is especially manifested in physics and chemistry, I would say, and concerns especially the notion of teleology, among other things. One of the characteristics of this attitude is an idea of the unity of the sciences. You might have heard this term, which is a euphemism actually for a hierarchy of sciences. Where physics is ontologically and methodologically the most fundamental. The oft-used but actually very little understood term, reductionism, expresses a motivation, a motive to explain higher-order phenomena in terms of lower-order mechanisms, but it hardly expresses a method for how exactly to do so. So it remains a motive, I would say, rather than an actual method. It is the belief that higher levels of analysis are merely matters of convenience, and that the best level of description for all phenomena is the lowest level. And there are also pragmatic non-reductionists or pragmatic holists, I would say, who endorse an in-principle possibility of reduction. However, in practice it would be extremely difficult and scientifically not worthwhile. For instance, in principle, human behavior can be reduced to the behavior of quarks, but to do so would be computationally very difficult. And so psychological analyses are a pragmatic approximation, they would say. But many phenomena at the organismal and individual levels of analysis cannot, and in principle should not, be reduced to smaller units of analysis. So a better way is to begin with a series of levels of organization and analysis, each defined by strong causal reactions of entities at that level among themselves, and then trying to understand how entities and causes at one level can affect entities and causes at another level, moving either up or down across levels. And the level on which a phenomenon is best described will be determined not by edit, like lower is better, but by the phenomenon itself and the questions asked about it. But the reductionistic perspective is not the whole of science or of the scientific attitude, I would say. We get a very different vision of science when we take, at least as a thought experiment, but luckily a little bit more than that, not physics but biology as the fundamental of science. And what I mean by this is taking the methods and the epistemic perspective of biology as the fundamental one. And maybe Aristotle could say, why not ontology too? Well, maybe. So this conception wouldn't result in an idea of the unity of the sciences in the sense I described. You need many sciences to understand even a single phenomenon. Now we conceive natural entities as multidimensional complexes in the epistemic sense of these, which require multidimensional forms of inquiry. There are also disciplinary reductionisms, by which I mean disciplinary attitudes in science to treat their associated methods and even ontologies as primary, and a sort of resistance to the idea that we should seek interdisciplinary connections in the way of knowledge synthesis. This attitude also stands in the way of understanding complex phenomena in complex ways, a different kind of reductionism. And this is the natural breeding ground for getting into false dilemmas or dichotomies, I would say, such as nature and nurture, or mind and body even. These are actually not real tensions in the sense of real intractable puzzles or incommensurable notions, I think these are rather disciplinary disputes between disciplines who insist on the primacy and sufficiency of their methods and postulates. So from the view of complexity, multidimensional complexity, I think they're stuck in an unproductive reduction, while they should strive for finding bridging principles and bridging mechanisms. Like, for instance, in the psychology departments in the US are commonly split into two sections, with the biological and cognitive enterprises frequently taking a third-person perspective on the one side, and the social and emotional enterprises often taking a first-person perspective on the other. So the concern with a division of this sort is that we lose the ability to understand many complex phenomena just because of the unnecessary disciplinary limitations which hinder any meaningful dialogue and knowledge synthesis. But the mechanisms that underlie a psychological phenomenon, for instance, and the functions that lead to its recurrence may not even be visible when the phenomenon is divorced from, let's say, its social context. So a perspective of multidimensional complexity, I think it is not an imaginary or counterfactual view of science. So not an account of what science could have only. Actually, this is how the sciences of complexity see the nature and its science. And this is one of the major approaches in life sciences, I would say, with a rich history of its own and a great potential for branching out to make intellectual connections to other scientific fields, as well as philosophy. And I will talk in the rest about some examples from this scientific perspective and try to show you actually how deeply Aristotelian it is. So life sciences deal with complex multidimensional problems, and that their inquiries require, for this reason, multiple questions spanning different but complementary exploratory dimensions. We can ask for any given phenomenon several questions. We can ask, how does it operate? So what are its immediate physiological or environmental causes? We can ask, how does it develop? How does it appear and change during the organism's life? How did it evolve over time? So how does it appear and change across generations? We can also ask, why does it happen? What are the events that follow it and lead to its recurrence? We can also ask, why does it exist in the first place? So what is its ultimate purpose or adaptive value? These are all meaningful scientific questions. So I will focus on one very prominent example, framework that originated in etiology, to later connect it to Aristotelian theory of scientific explanation. So one of etiology's founding fathers, Nico Tinbergen, a Dutch scientist, also a Nobel Prize winner, I guess, if I'm not mistaken, famously suggested that every student of animal behavior should ask these 4 questions to structure their inquiry. And these questions commonly go by these terms. Yes. First, the question about mechanism is actually a question about proximate mechanism. In other words, it deals with the immediate cause of behavior. The last, the question about function, asks about the ultimate mechanism. So it can also be seen as a mechanismic question. In other words, it asks which evolutionary processes, for instance, natural selection, have given rise to a given structure or behavior. If we are dealing with an adaptation, we might ask how it influences the reproductive success of the individual, for instance. The question about phylogeny, for instance, in the third place, asks about the history of any biological trait, morphological or behavioral. We have individuals of the particular species inheriting this trait from their ancestor, or is it a trait that represents an evolutionary novelty in a particular lineage? These kinds of questions. So thus we ask here about the origin of the trait separately from its function. These are different questions. And this is important because the traits that have originally arisen in order to fulfill some function may come to perform a completely different function, or may have not have any function at all in phylogenetically related species. And finally, we may ask what developmental processes have shaped a particular behavioral or morphological trait. So this includes studies which would test, for instance, the flexibility of a particular behavior with regard to various environmental influences, whether different developmental periods are specifically sensitive to like sensitive periods for development, and so on. So different academic fields might tend to single out and mainly focus on one of these questions. For instance, neurophysiology would tend to address mainly the question about mechanism. In contrast, phylogenetics would tend to focus mainly on questions about the history of the species. And frequently we may find scholars who treat the various types of hypotheses as if they were in conflict with one another. However, the answers to the individual questions are not mutually exclusive, as they simply address different aspects of phenomena. And there are some earlier accounts as well, which have interestingly similar sort of classifications. So this is by Huxley. The only difference from Tinbergen is the aspect of ontogeny or development that Tinbergen added. So what is less evident, these questions, the similarities between various, like let's say, cognate classifications show that these questions are fundamental to the study of living systems. But what is less evident usually to scientists and historians is that, which is familiar to students of natural philosophy, like us, that we owe much of this to Aristotle, actually. So I think our modern understanding of scientific explanation has not moved too far away from Aristotle, who famously maintained that to explain a phenomenon is to identify its appropriate cause. It means it only involves stating the cause why the thing is, that it is the cause, and that it cannot be otherwise. This is from posterior analytics. I will place particular focus on how Aristotle understood natural forms, of course. In the Anima, he says that the adequate definition of a natural form should be as a certain mode of movement of such and such a body, or part of, or a faculty of a body, by this or that cause, and for this or that end. So this is because natural forms are inseparable from matter in a different way than mathematical or geometrical forms would be. I will revisit all these later in the talk. So if we go about filling the blanks in the formula for an adequate definition, we can ask 4 fundamental questions, right? These refer not to 4 different causes per se, as could belong to different entities, but to 4 different explanatory roles a factor can play, which in turn corresponds to 4 different kinds of causation that might be captured in these explanatory roles. So the Aristotle's efficient cause would ask about the immediate agent. We can add to it or a process causing an event. Material cause asks about the underlying substrate, or we can add, I think, conditions enabling development. The formal clause asks about the form or essence. We can maybe add form or essence as shaped by evolutionary history. Final clause asks about the end or purpose for which something exists. This can be a local or an emergent purpose as well. So a rough mapping could look something like this. You would remember from the earlier Tinbergen fourfold classification. These, I think, are peculiarly similar. To talk a little bit more. So the mechanism for Tinbergen would be the immediate physiological environmental stimuli that releases a behavior, because he's an etiologist. The efficient cause for Aristotle would be the immediate agent or process that elicits an activity. I guess this would be the most obvious of the connections. So I will have examples of this a little bit later, but I will spend less time on it. What about ontogeny and material cause? Maybe this is the least obvious one, but I think there are still some similarities. So the Tinbergen's question was, how does the behavior develop over organism's lifetime? The material cause asks for the underlying substrate or conditions enabling development, as I said, possibly. So according to Tinbergen, the question of ontogeny addresses timing primarily, like questions about at what age does a behavior first appear. But more importantly, it also asks how previous experience has shaped the current behavior, or whether learning processes have been involved at all. This is similar to Aristotle's note that an individual is shaped by various environments or experiences. And lastly, an account of ontogeny should involve processes like developmental constraints or a canalization of learning processes. This brings us still closer to Aristotle's material cause, because it points to characteristics and constraints given by a specific method. So Aristotle also has developmental theories, of course, like we have on the generation of animals, the conception of the embryo from the combination of male semen and female menstrual blood. They are both products or residues of metabolic processes of concoction, and the quality of the semen and the menstrual blood matter depends on the degree of success of this process. So the semen acquires a varied capability to form a new living being, and it enters the menstrual blood that may have varied potentiality of being informed by its semen. So the same form may be realized more or less perfectly in different matter provided, let's say, by the female. The notion of material cause may also be extended to different parts of the body of the living beings, with their respective characteristics that determine and limit their functions. Furthermore, the qualities of a particular matter out of which an animal is composed are also connected with its habitat, most notably with whether it lives in the water, air, or in the earth, on the earth. In modern biology, this habitat is very similar to the environment of evolutionary adaptiveness. And finally, Aristotle also acknowledges that animals change territories according to season, and these territories can vary according to location and climate. This too, I guess, or so to speak, the material conditions in which they live. These also belong to the study of the material cause. So what about phylogeny and formal cause? So phylogeny asks about how did the behavior evolve over the history of the species. The formal cause asks about the essence. As I said, maybe this can be shaped by evolutionary history. So for Aristotle's form, which we may say defines a particular species, in comparison with post-Darwinian biology, is of course immutable, and it's not a product of evolution. But apart from this difference, however, I think it has the same function as the term species in modern biology, which, although unchangeable, not unchangeable as Aristotle had it, is stable and determined over the long term. It definitely has a certain stability. It is not under an ongoing change. So we are still interested in the stability of the form. So at first glance, maybe when we look at questions about phylogeny, they might seem to be again primarily about the timing, like timing questions. Like when does a trait, like a morphological property or a behavior, first appear in the history of the species, for instance. And this might suggest that the study of phylogeny has just little to do with the Aristotelian form. But the study of phylogeny also involves questions about predecessors and why their descendants resemble them. In terms of current science, we can speak about the inheritance of appearance or form, so to speak. Furthermore, the characteristics of a particular species predetermine its appearance and behavior. This resembles, I guess, Aristotle's general form. So through the power of abstraction, we distinguish these general forms from individual forms subsisting in concrete things and living beings, although these are not separable in reality. The individual form, which is the result of individual history, would fall under the question about ontogeny. So Aristotelian form falls under both phylogeny and ontogeny in the sense that they're actually the same in reality. We only separate them in abstraction. What about the last one? Function, in the sense of adaptation, like what is the adaptive value or purpose of a behavior in comparison to Aristotle's final cause, the end or purpose for which something exists. Aristotelian final cause is obviously one of the most controversial issues of his philosophical and scientific legacy for the scientists. An important portion of the contestation, I guess, is due to a conflation of Aristotelian ideas with the ideas of intelligent design, or due to a resistance to a global teleology, but not necessarily to an imminent and local kind of teleology. I guess this is not the point of contestation. So somebody had mentioned, I guess yesterday, the term teleonomy as well. This is actually a word biologists had made up in order just not to say teleology. It is the same word. So it's originally proposed by Tunc, so some 70 years ago or something. And it meant apparent. Kant used to say the same thing. Purposefulness and goal-directedness of structures and functions in living organisms brought about by natural processes like natural selection. And Meyer applied the same term, teleonomic, to systems operating on the basis of a program of coded information. He says the existence of a complex codes of information in the DNA of the germplasm permits teleonomic purposiveness. On the other hand, evolutionary research has found no evidence whatsoever of a goal-seeking of evolutionary lines, as postulated in the kind of teleology which seeks plan and design in nature. The harmony of the living universe, so far as it exists, is an a posteriori product of natural selection. So, a rejection of global teleology, but an endorsement of local and imminent teleology. So it is a common, I guess, endorsement that information accumulates in nature about functions and structures that are successful. So exploiting feedback from the environment via the selection of fitter coalitions of structures and functions. Robert Rosen famously has described these features as an anticipatory system, which builds an internal model based on past and possible future states. So without some concept to describe this historical learning or memory we see in nature, we won't have the concepts like emergence, complexity, and self-organization, which are now ubiquitous and indispensable in biology. So one more from William Wimsatt, a much older colleague of mine from Chicago. And he says, as scientific knowledge of a phenomenon increases, so a history of science, models move with increasing sophistication from more atomistic and aggregative to more structured, interactive emergence. So when you look at the development of a particular science, he says he sees a pattern that they begin always with abstract, atomistic, and models which deal with more aggregative properties. And as long as we move on and learn more, models become more structured, interactive, and they are able to deal with emergent properties as well. So it is just a lack of knowledge that we have more reductionist or schematic models. So this is from Meyer again. Two examples. Why do we need teleonomic explanation? The wood thrush migrates in the fall in order to escape the inclemency of weather and the food shortages of the northern climates. You can also say the wood thrush migrates in the fall and thereby escapes the inclemency of the weather and the food shortages of the northern climates. So if you replace the words in order to escape by and thereby escapes, we leave the important question unanswered as to why the wood thrush migrates. The teleonomic form of the statement implies that the goal-directed migratory activity is governed by a program. This is Meyer's terminology. By omitting this important message, the second sentence is greatly impoverished as far as the information content is concerned, without gaining anything in clause's strength. So if I now take a step back before going into more detail, I can say a few general things about Aristotle's legacy. There have been several Aristotles, as known, active over the course of history, the Aristotle of contemporary scholars of ancient Greek philosophy are clearly different from more traditional Aristotle thought at universities since the Middle Ages. The latter owes much to the systematization of Aristotle's thought as promoted by the Neoplatonists in late antiquity, who placed his concepts within a global hierarchical framework of their metaphysical universe, deduced gradually from the first principle of all. Aristotle's great medieval commentators, Averroes and Aquinas, owe much, or at least a substantial amount, to this reinterpretation of Aristotle's thought. But one can still find some traces of it in, for example, even early 19th century natural theology. The other Aristotle is represented mainly by his biological writings. This is my interpretation. Unlike Aristotelian physics and astronomy, which was heavily criticized and had already been abandoned by the Renaissance scientists, Aristotle's biology continued to be studied and further elaborated in the early modern period. Here is an old Charles Darwin who enthusiastically greets a recent made translation of the parts of animals with this famous quote. So, Linnaeus and Cuvier have been my two gods, though in very different ways, but they were mere schoolboys to the old Aristotle. Needless to say, a metaphysician or a theologian would read Aristotle very differently. And it is possible to read Aristotle in many ways. It is historically a little bit less well studied, maybe, and often presents some conceptual tension with these. But the natural philosophy, and especially the biology and psychology of Aristotle, is not less powerful. And it is, in some subtle ways, much more relevant for modern science than the former. So despite all the paradigm shifts and broadening of our knowledge of the natural world over the centuries, I would say Aristotle's general framework for the study of natural phenomena is still a viable heuristic concept. From a historical perspective, I think of Aristotle as the one who, for the first time, marked out the field naturalists still play on. So the main heuristic value that I mentioned of Aristotle's method for modern science is that researchers may ask fundamental questions about the nature of living beings, which, however, address mutually irreducible aspects of their nature. Although in theory we may separate them for the sake of inquiry, in living beings, these aspects are always interconnected, which is Aristotelian form and matter, or Timbergen's phylogeny and ontogeny. In some specific cases, it is not even possible to make a clear-cut distinction between them. The significance of these distinctions can be found in instances when scholars actually forget about or are unaware of them. For example, in the 1990s, the evolutionary behavioral sciences were characterized by very fierce, often unfruitful debates between the schools of evolutionary psychology on the one hand and human behavioral ecology on the other. Only subsequently has it been acknowledged that these schools of thought may not be as incompatible as it at first seemed, but rather that one mainly focus on proximate mechanisms, which is evolutionary psychology, and the other on ultimate causes. Today, these coexist. So these heuristic principles that I mentioned can be very roughly summarized as these ideas. Valid scientific explanations can coexist at different levels of description. Different levels serve different goals of understanding. And descriptions across levels need not be mutually exclusive. For instance, we can say that every psychological theory could, and maybe even should, have a biological theory. But the reductionist version, for instance, neural instead of psychological, is not more correct. It just addresses a different question. I collect these heuristic principles under what I call Aristotle's dyadic approach, for lack of a maybe better term. What are dyadic explanations in general? In order to fully understand the phenomenon, it is necessary to understand not only the preceding events that cause it to happen, its mechanism, but also the subsequent events or consequences that cause it to happen again, creating a class of similar phenomena, which is its function, let's say. This is an explanatory diet, I would say. This is one example. Aristotle used the terms efficient cause and final cause, respectively, to distinguish these two types of causal explanations. An example from modern science: the coordination of the estrous cycles within groups of female rats. It has both a functional and a mechanistic explanation, or mechanismic explanation. So the majority of female rats within a group is likely to be at the same phase of the estrous or menstrual cycle on the same day, as famously discovered by Barbara McClintock. The synchronization of fertility allows the coordination not only of mating, but also of fertility and infant care within the group, and thus leads to increased survival of the group's young. This is a functional explanation of the synchronization, an explanation that focuses on the effect of the phenomenon on reproductive success, which is a major component of evolutionary fitness. At the same time, temporal coordination of the cycles occurs as a result of pheromones. Pheromones are an olfactory signal that advances the underlying rhythm of the cycle, thereby either shortening it or lengthening it. So they communicate with these olfactory signals. So pheromones are a kind of smell that we usually subconsciously process. So there is one olfactory signal that advances the rhythm, thereby shortening it. And there's another olfactory signal that delays the rhythm of the cycle, thereby lengthening it. So this is a mechanistic explanation of precisely the same phenomenon, an explanation that focuses on the effects of the other events on the phenomenon itself. Neither explanation is better than the other, as you can see. Both are important to understand this phenomenon of synchronization and coordination of fertility in a group of rats. An example from Aristotle, which I decided to juxtapose to this, is how he defines anger. So it is the boiling of blood around the heart induced by perceived injustice with the function of rectifying that injustice through behavior. Let's paraphrase a little bit. And today's psychology of emotions, I guess, would characterize anger in a also strikingly similar way. They would say it involves a cognitive appraisal of unfairness towards the self, creates a physiological readiness for a conflict, such as the increase in cardiac output, which would be also explained as an evolved mechanism. Another diet, ontogeny and phylogeny. So these are a complementary and interactive conception of evolution and development, which is pretty, I would say, mainstream, became mainstream in the life sciences. So in Tinbergen's analytical framework, innate so-called patterns may contain elements that at an early stage developed in interaction with the environment. And on the other hand, learning is from step to step limited by internally imposed restrictions. We can also say that there are also behavioral patterns which do appear in the inexperienced animal, but only in incomplete form. And they require environments to put input for additional development through learning. So currently there's knowledge of even more complex interactions, I would say, especially in epigenetics, which suggests that innate patterns may involve potentiality for various different developmental outcomes. And developmental experiences of the organism may influence how certain genes will be expressed even in the offspring. So this is not a Lamarckian idea, but almost sounds like one. So from this perspective, the most heated debates on nature versus nurture, from today's perspective, are simply misguided and fruitless. What it means to be so-called innate depends entirely on the time span within which a phenomenon is considered. I'll give a few examples. The term innate has different meanings on different time spans, and it ought to be modified to reflect these differences if it's going to be a useful term. So on the momentary time span, a behavior is often considered to be innate, internal, intrinsic, if it appears to run off independently of features of the environment. So this might be familiar to you from like the seemingly automatic behaviors of simple animals, like ants and bees, for instance. And they would continue these automatic behavior sequences even if you would modify the environment in a way that the behavior becomes utterly meaningless. So they will be just caught up in weird loops. A famous example from Tinbergen was the mating behavior of butterflies, so the mating approach behavior. So one species of butterfly is particularly attracted to a bright red torso in the other sex. So what they did was experimentally manipulate sort of the quality of this stimulus. They began with a puppet, which looks like a butterfly. Okay, same advancing behavior. Then they took out the antennas, same advancing behavior. They took out the wings, same advancing behavior. In the end, what they were left with was a red pencil, like really. And the butterfly behaved exactly in the same manner, advanced towards the pencil. And in the last phase, they presented the red pencil along with another butterfly, which only had a less bright shade of red on the torso, a real butterfly. The male went for the pencil. So this kind of automatic behavior. You might think that these are like, okay, very stupid animals. They have an algorithm, and this is like entirely in genetic code. This is why it is stupid. My point is definitely not that. So this could be the case, but not always. There are examples of such things also in humans, not genetically determined. For instance, when we hear something which is barely audible, let's say a lot of noise. So we are hearing something, somebody is speaking, but we have difficulty making out the semantics of it, let's say. What we do commonly is we do something like this. What does it have to do with it? It is meaningful if it allows us to discern the lip movements a little bit better, of course, because then you combine information and you can discern the meaning a little bit better. But in the experimental context, people do it even when they're on the phone, or even when they're listening to a recording, voice recording. They do this as if it will help. So this can be called an innate behavior, although it is definitely not genetically innate. It's innate in the momentary sense. Just an example. What is an ontogenetically innate behavior? People usually call an ontogenetically innate behavior if, for instance, it appears in the young animal almost fully formed. Some animals might begin mating immediately, or food foraging immediately, or even migration-related activities immediately. Or you can also say it's something is a trait is ontogenetically innate if it shows very little to no plasticity during development. And finally, you can call something phylogenetically or genetically or evolutionarily innate if it has something to do with the genome, definitely. If, in a more technical sense, you would say if the behavioral mapping of the species would create the same kind of mapping with the phylogenetic mapping of the same species, but you don't need that. The interesting point is that these senses can come apart, so that's why it's useful to differentiate. For instance, an example is this PKU, is difficult to pronounce. It is an inherited disease resulting in severe mental retardation, especially in kids, but also in adulthood. It is possible, however, to prevent the mental retardation by simply restricting the protein intake of the baby in the dietary environment up until 3 years old or something. So it is inherited, and you can also you will give it to your offspring, but it is possible to completely prevent any mental retardation, any manifestation of this trait, just by not limiting the protein intake. So it is innate in the evolutionary sense, but not innate at all in the developmental sense. Another idea is, like again, a dyadic explanation, how I do with time.
I think you have 5 minutes or so for the presentation.
Okay, I guess I can do it for 5 minutes. Okay, I will leave out more textual exegesis of Aristotle because everyone is an expert in Aristotle already, so I will talk about different things. This idea of levels of organization and analysis being maybe dyadic. So mechanistic causes may work bottom up or top down, and there's no reason to expect the mechanisms that account for a phenomenon to reside completely at a lower level than the phenomenon itself. Just 2 examples. Effects of lower mechanisms that work upward, more typical, studied. A female rat's hormonal state would influence whether she will solicit a female rat to face mating, like estrogen and progesterone hormones, binding to specific parts in the brain and so on, and these are sufficient to create this behavior. Example of effects of higher level mechanisms that work downward, which are less often studied, but equally powerful. For instance, the effect of behavior on hormones. So the Rose and colleagues first established the male monkeys, so in the study, male monkeys' testosterone levels when the male monkey was alone. After the male was placed in a cage with a group of female monkeys, his testosterone levels began to rise in the company of females, only to fall back to the baseline when he was removed from the female cage to his own. Then, when placed in a cage with other males who were above him in the social dominance hierarchy of the monkey group, his testosterone levels dipped well below his baseline levels. Even after he was removed from the male cage and placed in a cage alone, his testosterone levels remained well below the baseline, demonstrating how powerful and long-lasting effects a social experience can have. Just the presence of the kind of social company it keeps makes such a profound effect on the testosterone levels, which is a very sort of low-level biological phenomenon. Functional causes also operate at different levels and during different sort of lifetimes. So I can skip this example. We can also talk about perspectives as dyadic explanations. Maybe a common example, I won't talk about all of them, but Durkheim's work on sociological work on suicide was surprising because the phenomenon was studied mainly psychologically until that point. And then he decided to study it not from the first-person perspective, but from the third-person perspective, and at the social sort of level, and discovered then patterns and regularities with predictive power and explanatory power that were not visible to the psychologist from the first-person perspective. One odd example, so we can talk about many good examples, of course, which were sort of well cited. I was even going to talk about Ipsius and Umwelt a little bit, but let me give you a very odd example. So, in a not so recent study, but it is well replicated, individuals identified as having multiple personality disorders. The study is on that. It was found that they have a different sense of self when they are in each personality. So these different subjective perspectives within the same person have physical manifestations that can be measured and quantified. So this is the weird finding. So in this study, an optometrist, which is blind to the goal of the study, was asked to conduct several optometric evaluations on each of a series of individuals. Some of the participants in the study had multiple personality disorders, and they inhabited different personalities during repeated eye exams, while others did not, and they maintained a single personality throughout. The finding is that the variance in visual acuity between evaluations, eye examinations, was 10 times greater for the individuals with multiple personality disorders than for the control group. So it seems that each personality appeared to have its very own visual profile, as can be detected by an optometrist. So here you see that without having these two perspectives, like the psychologist, clinician's perspective, and the optometrist's very sort of psychophysical perspective, you wouldn't even detect that this is a phenomenon. So then, to close maybe, without going into too much detail, I can try to abstract and summarize what I think Aristotle's dyadic approach is, which sort of influenced these kinds of multiple and complementary questionings. I think it is characterized chiefly by accounting for any phenomenon at hand by determining two asymmetrical but complementary aspects of it, and explicating the nature of their interaction. So a positive assumption of this approach is that one needs to represent the phenomenon from at least two scopes, angles, or aspects at a time, otherwise the phenomenon is not understandable. The negative assumption is that no phenomenon can be approached monodimensionally, so a rejection of reductionism. And I think there is an ontological postulate behind this method of explanation, and that it is any entity, especially any ensouled entity, let's say, following especially your talk, originates from and persists by virtue of a basic interaction. And I think this account, its original form, is based on his sort of philomorphic account of nature, so his usage of natural form and matter, and the diets of actuality and potentiality, which he uses interchangeable in contexts. So both consist of very relative terms and they are complementary. They have to be, it means they have to be identified depending on the entity in question, and they're not identified in absolute ways. And the identification itself is, again, for want of a better term, I would say it is sort of functional. It is more about not what an entity is, what something is, but it's more about. Sorry. It's not too important, but I can try it. So I was trying to make it the last slide. Anyway, I guess it is not with the screen. It will be okay.
With some, I think it's with the
Connection?
with the machine somehow. Went to speak.
Okay. Yeah, probably. This one tries to display it. It sends the signal again and again. Send again. Try it like every 2 minutes. I told you this word when the machine at war. It wants to stop.
You don't have energy It lost the organs. Perhaps the lamp went out or something.
Yeah, if the lamp went out, then
Yes.
you
No,
no
it's
longer
on.
need.
It's on.
Oh, okay, it's on. It's on. It's on.
Oh,
It's back on.
okay,
Yeah.
great.
You still have a lamp going on. You can leave it. You can use it. Yeah. Yeah, but like probably the lamp is approaching the end.
Gradually re-emerge.
Okay, brightness is it. So yeah, so I'm sure you like if it makes sense at all, like you will be able to fill in the details. I don't want to go about explaining Aristotle to you, but I think basically the ideas of how like account of generation and transformation, especially not his account of alteration per se. Or how he accounts for change in the logical world, like in the organon, but how he accounts for generation and transformation, how he uses the hieromorphic framework, and these particularly manifest this dyadic theory of scientific explanation, or this heuristic approach to scientific explanation. And it also already involves an idea of levels of organization already at that time, I think. One example is his notions of proximate and remote matter. Let me see. So just a few examples then to begin with. So this notion of form in the Aristotelian context involves like two senses which may or may not correspond at all cases. The sense of essence, which has to do with definition, and the sense which spans from like geometrical features to structure, organization, or function, comprising like all kinds of features which we would arrive at through change. So Aristotle natural works, the hylomorphic form is very closely connected with matter and change, and cannot be thought independently of them. A natural form, as opposed to a mathematical one, must be capable of accounting for the capacity the natural body has to change. And if it is not defined in a way that refers to natural bodies in which it is realized, it wouldn't have this explanatory power. So one basis for this argument is the distinction he makes in Book 2 of Physics, where he argues that features like odd, even, straight, or curved, or number, line, and shape can be defined independently of change, but flesh, bone, and human cannot, because their features, a famous example is like snugness, is not like curved, it's something different. It requires taking nasal flesh into account, because if it were treated separately from matter, it would not be what it is, but it would be more like the abstract feature of concavity, something like that. Its natural forms would lose some of its essential properties if they're separated from matter. It's one idea that we can get from here. So I said that they are identified through the roles they play or through the functions they play in the constitution of composites, form and matter. So for this reason, what is indicated as a formal feature of a particular composite may well be identified as a material feature in the context of a higher level composite, whose matter is that particular composite, and vice versa. In other words, inherent forms of proximate matter of a composite may be regarded as material features of the composite, and material features of any composite may themselves be the formal features of proximate and remote matters. Forms make use of other forms of lower levels, and the form utilizes them as matter for its operation. We talked about organs, we can make it broaden. Molecules, cells, and so on, form uses other forms to operate. And considering that matter is the seat of change, we have to say that form, through its operation, brings about changes and modifications in the formal features of its matter. So this portrayal of hylomorphism leads us to the idea that reality is made up of integrated levels of organization, I would say. And he is the originator, he is at least in this modern sense, I guess, originator of this idea. For instance, we can say that these are all material properties, like solidity, conductivity, and shape, for instance. Conductivity is a result of fine microstructure and low-level operations. Solidity is a medium-scale feature, and geometrical shape is a global macroscopic feature. So we can define them as formal features at different levels. And regarding form, maybe we can give the well-known example of different kinds of soul or psychic powers, which are identified through their functions and correspond to different levels of organization. Similarly, so he would say that the appetitive power requires for its existence that the animal already has functioning senses. The power of thinking in animals requires imagination, which in turn requires sensibility, all of which requires the operation of nutritive and reproductive power. Yeah, I guess I should stop there. So I was going to talk about how he thought about maybe essential and existential essential changes continue, but I can maybe leave that out and just say that from all these examples, what I wanted to get at is that a full explanation of a phenomenon will often require not one, but a whole set of explanations at different levels of organization, including time scales, perspectives, and different causal modes. And many conceptual confusions, such as the nature-nurture dichotomy or the mind-body problem, can be seen as a product of different choices of preferred locus, logi, within the different explanatory dimensions, either stemming from an explicit argument that one choice is better, or from a failure to notice that there are even choices. So there can be a best choice on the explanatory dimensions to answer a given question for a given audience in a given context. So we can talk about a better choice or the best choice. However, what makes an explanation a good explanation, a good scientific explanation, is relative to the very question asked and the audience and the context addressed, and it is not an absolute matter. So complex multidimensional problems require multidimensional complex answers. And this approach, I think, is both originated and exemplified by Aristotle.